Myself Ashok, Assistant Professor, Computer Science Department from Rohini College of Engineering and Technology. In this video, we are going to see about Hadoop and Mapreduce. Hadoop is an open source implementation software coded and released in Java by Apache. The Hadoop implementation of Mapreduce uses the Hadoop Distributed File System HDFS as its underlying layer rather than Google file system. The Hadoop core is divided into two fundamental layers. One is MapReduce engine and another one is HDFS, Hadoop Distributed File System. The MapReduce engine is the computation engine running on top of Hadoop Distributed File System as its data storage manager. Hadoop Distributed File System is a distributed file system inspired by GFS that organizes files and stores their data on distributed computing system. In Hadoop distributed architecture, Hadoop distributed file system has master-slave architecture containing a single name node as the master and number of data nodes as workers. To store a file in the architecture, HDFS splits the file into fixed size of blocks and stores them on workers node. The name node means the mapping of blocks to data nodes is determined by the name node. The name node is the master node. It manages the file system's metadata and namespaces. Namespaces is the area maintaining the metadata. Metadata means refers to all the information stored by the file system that is needed to overall management of all files. Then data node. Each data node, usually one per node, is cluster and manages the storage attached to the node. Each data node is responsible for storing and retrieving file blocks. The HDFS feature is fault tolerant. Hadoop considers the following issues to fulfill reliability requirements of the file system. One is block replication, replica placement, then heartbeat and block report messages. The HDFS main operations are write and read. To read a file in Hadoop file system, a user sends an open request to the name node. Name node means master, to get the location of file blocks. For each file block, the name node returns the address of a set of data nodes containing replica information for the requested file. The number of addresses depends on the number of block replicas. Upon receiving such information, the user calls the read function to connect to the closest data node containing the first block of the file. After the first block is streamed from the respective data node to the user, the established connection is determined and the same process is replicated for all blocks of the requested file until the whole file is streamed to the user. To write a file in HDFS, a user sends create request to the name node, the same master node, to create a new file in the file system namespace. If the file does not exist, the name node notifies the user that allows him to start writing data to the file by calling the write function. The first block of the file is returned to an internal queue termed the data queue, while a data streamer monitors its writing into a data node. Since each file block needs to be replicated by a predefined factor, the data streamer first sends a request to the NameNode to get a list of suitable data nodes to store replicas of the first block. The streamer then stores the block in the first allocated data node. Afterward, the block is forwarded to the second data node by the first data node. The process continues until all allocated data nodes receive a replica of the first block from a previous data node. Then the next thing is MapReduce. The topmost layer of Hadoop is the MapReduce engine. MapReduce engine manages the data flow and control flow of MapReduce jobs over distributed computing system. So see the Hadoop file system and MapReduce architecture. So top there is a master node and there is a data node. So data node is a slave and the master node is namespace, NameNode. MapReduce engine also has master-slave architecture consisting of single job tracker as the master and number of task tracker as the slaves, which means workers. The job tracker manages the MapReduce job over the cluster and is responsible for monitoring jobs and assigning tasks to the task tracker. The task tracker manages the execution of map and reduce tasks on the single computation node in the cluster. Each task tracker node has a number of simultaneous execution slots. Each execution either a map or reduce task. Slots are defined as the number of simultaneous threads supported by CPU of task tracker node. For example, task tracker node with n CPUs each supporting m threads has m into n simultaneous execution slots. It is worth noting that each data block is processed by one map task running on single slot. Therefore, there is a one-to-one correspondence between map tasks in the task tracker and data blocks in the respective data node. Thank you.